Hello everyone. We are excited to announce that the automatic tilt adjustment feature of our Wanderer ETA is finally here. In this video, I will walk you through a step-by-step tutorial on how to use this groundbreaking function. To ensure everything works seamlessly, it's very important that you carefully follow the instructions and configure all parameters correctly. Let's get started and unlock the full potential of your Wanderer ETA. First, please make sure your Wanderer MPI software is updated to the latest version. Next, connect your Wanderer ETA to the software, and you will notice that the automatic tilt adjustment panel in the top right corner of our software. Within this panel, the software will guide you step by step through the entire configuration process, helping you set all necessary parameters to ensure smooth and accurate operation. First, we need to install and configure the Hocus Focus plugin. So let's go back to Nina. In Nina plugin section, we find the Hocus Focus and install it. On this PC, it is already installed. If you haven't installed it, you need to install the Hocus Focus plugin and restart the Nina software. After you have installed the Hocus Focus plugin, go back to Wanderer MPI software. You can see that it says that under the Hocus Focus autofocus option, we need to select the save option and specify a save path. To do this, let's go back to Nina again, and let's find the Hocus Focus plugin in the list of installed plugins. By default, the save option is disabled, so we need to manually enable it. Next, we need to choose the save path. In this example, we are selecting the HF folder located on the D drive. It's recommended to choose a location with plenty of available storage, as the Hocus Focus plugin can take up space over time. Go back to Wanderer MPI software and choose the same path. After that, simply click Next to proceed. The next step is to determine the step size of your focuser. The step size refers to the distance in microns that the focuser tube moves with each step. For integrated focuser, for example, the Optec TCF Leo, the step size is usually provided by the manufacturer. However, most users may be using external focusers, such as the ZWO EAF. In these cases, the step size is not fixed and depends on the specific telescope being used. For example, if you install the EAF on a Takahashi telescope versus a Sharp Star telescope, the step size will differ due to the mechanical characteristics of each focuser system. If your telescope is right next to you, you can move your focuser. For example, move 2000 steps. Then you measure how many millimeters your focuser tube has moved. To calculate the step size in microns, simply divide 2000 steps by the number of millimeters moved, and then multiply the result by 1000. This will give you the step size in microns per step. At the same time, there is also a reverse checkbox. If increasing the step moves the focuser tube inward, check reverse. If you are not sure or unable to measure these parameters, for example, the equipment we are showing is in a remote observatory, we can't measure it. Then we click Measure. Our software will automatically determine these parameters. Now let's click Measure in the Wanderer MPI software. A dialog box will appear, prompting us to run a Hocus Focus session in Nina, specifically using the Aberration Inspector tool. So now, let's switch over to Nina. If you have successfully installed the Hocus Focus plugin, you will see the Aberration Inspector in the Imaging section of Nina. Click on the Run Autofocus to start the process. Now, all we need to do is to wait for the Aberration Inspector process to complete. Now the Aberration Inspector completes. Let's click OK. It will pop up a confirmation dialog to confirm whether the Hocus Focus has been completed. Just click OK. Now the ETA will move and do not operate during the operation until it prompts you to do the next step. Now it's done. It prompts us to run the Hocus Focus again. Let's go back to Nina's Aberration Inspector. Then click on the Run Autofocus and wait for it to run. Now the second Hocus Focus session is complete. Click OK to confirm. You will see that the software has now measured the step size. In this case, it's 4 microns per step. It also automatically determines whether the reverse option should be enabled. In our case, there's no need to check reverse, so we can go straight to the next step. The next step is to set the relative angle between the camera sensor and the ETA. This angle is very important, and the more accurate it is, the better. If the value is significantly off, it can seriously affect the accuracy of the automatic tilt adjustment process. If you are not sure how to determine this angle, don't worry, you can click on See Examples for guidance and visual references. The angle is defined as the clockwise angle between the long-side symmetry axis of the camera sensor and the symmetry axis of the ETA. The valid range is from 0 degrees inclusive to 180 degrees exclusive. There's a diagram below that illustrates this concept clearly. You should be able to understand how to determine the correct angle by referring to the diagram. The white rectangular represents your camera sensor. Let's go over some common examples. Take a look at the first image. Here, the ETA is directly mounted to your OAG using screws. In this setup, everything is aligned, and the angle is 0 degrees, as shown in the first diagram. Now, let's look at the second example. This time, the ETA is directly attached to a camera with screws. You will notice that the camera sensor is tilted, and in most cases, the angle is 30 degrees. If your setup is different from these two examples, you will need to measure the angle accurately and enter it manually. In this case, we install the ETA directly to the QHY OAG via screws, so the angle is 0 degrees, so we enter in 0 degree. There is also a checkbox called Upside Down. Do not check it yourself. You have to click Measure to let our software automatically analyze whether you have to check it or not. Now, let's click Measure. The software will prompt us to run another Hocus Focus session. However, since we have just completed one in the previous step, and the ETA did not perform any adjustments, so we can simply reuse the previous Hocus Focus result and click OK. The ETA will now make a movement, and please wait until the movement is fully completed before moving on to the next step. Now it asks us to run Hocus Focus again, so we go back to Nina and click Run Autofocus. Then just wait for it. Now we have completed the second Hocus Focus session. Simply click OK and then OK again to confirm. It prompts that Upside Down should be enabled in this case, and it will automatically check it for you. Just click OK to proceed. Now click Next Step. The next step is very straightforward. It's about setting the size of your camera sensor. You will see two preset options, but you can also enter the values manually if needed. In this demonstration, we are using a QHY 600 full-frame camera, so we'll simply select full frame and then click Next. So far, all parameters are set. If you don't change your camera or your focuser, these parameters can be used forever. If you change them, you can click the Reset button at the bottom right to reset the steps we just did. After setting these parameters, we just need to run the Hocus Focus autofocus in Nina and then click the Automatic Tilt Adjustment button. Actually, we have just finished a Hocus Focus session in the previous setting, so we don't need to run it again now. Before applying the Automatic Tilt Adjustment, let's take a look at the results of the Aberration Inspector. You can see that the tilt arrow is very large, almost near 100 microns. Let's take a shot to see how the stars look. As you can see, the stars are distorted on the corners. Now, let's click the automatic tilt adjustment to begin the correction. It will show you the credibility of the adjustment. This credibility is determined by the results from the aberration inspector. You will notice that there are 4 points here: top right, top left, and bottom right. The credibility indicates the coplanarity of these 4 points. The better their coplanarity, the higher the credibility. If the credibility is above 80%, everything is good. You can confidently click OK and apply the new ETA position. However, if the credibility is below 80%, the adjustment may not be ideal. There can be several reasons for low credibility. The most common reason is poor seeing conditions or heavy light pollution, which can prevent aberration inspector from producing accurate results. Another possibility is that the Hocus Focus plugin is not properly configured. Make sure you can achieve a beautiful autofocus curve with aberration inspector. It's also possible that your camera sensor isn't perfectly coplanar, which can affect the measurements. In our case, the current result shows a credibility of 97.5%, which is very good, so we'll go ahead, click OK, and move the ETA to the new position. After completion, we can run again in the aberration inspector to check the results of the adjustment. You can see that the result is very good. The tilt arrow is within 10 microns. Generally, if the arrow is reduced to within 10 microns, the stars will be perfect at the corners and there's no need to further adjust it. Now let's take a shot and see what stars look like at the corners after the adjustment. You can see that the stars are perfect at the corners, and we can make a comparison. This is before the adjustment, and this is after the adjustment. We can also compare it in the tilt measurement history. This is before the adjustment, and this is after the adjustment. It is very amazing, right? After setting everything up, if you have any need to adjust the tilt, for example, after a meridian flip or a rotation of your CAA, you only need to run the aberration inspector once and then apply the automatic tilt adjustment in Wanderer Empire. It is very easy and straightforward, right? So that's all for today's tutorial of the automatic tilt adjustment feature of our Wanderer ETA. I hope all you guys can get rid of the trouble of tilt with the help of our Wanderer ETA. See you next time!